Why, hello there. Today we are going to be talking about rationalizing the denominator when the denominator contains something other than a simple square root. This process can be summed up very quickly by saying that we are going to multiply the top and the bottom of the fraction by some power of your variable that is going to produce a whole number power of your variable in the denominator. A fair warning to you, we will be using fraction operations quite a bit in this video, so if you're not confident about your skills there, I encourage you to watch the Auducation video about adding and subtracting fractions together. If you are comfortable with that, then I invite you to tag along. Ready-o? Let's go. Our first example is 1 over the cube root of x. Now, if we expect to get a whole number power of x in the denominator, we first have to get rid of the radical. So what we'll do is we'll take the cube root of x and turn it into x to the 1/3. Now we have to multiply the top and the bottom by some power of x that's going to turn this guy into a whole number. In this case, that's going to be times x to the 2/3. Why 2/3? Well, essentially what we're trying to do is turn the numerator of our fractional exponent into a multiple of its denominator. And we're going to see how that works out in just a second. 1 times x to the 2/3 is x to the 2/3, and then when you multiply like variables together, you have to add the exponents. So we're going to have x to the 1/3 plus 2/3. Interesting. When we do this addition out, in the top we still get x to the 2/3. That's going to stay the same no matter what. But 1/3 plus 2/3, that's 3/3. And hey, look at that. We can now simplify this fraction in the denominator. So once again, x to the 2/3 in the top, and 3 over 3, that's the same as 1. And it's much, much easier to write this new answer as x to the 2/3 over regular x. And that is our answer. Our next example problem is the square root of x over the 4th root of x cubed. So once again, we're going to have to get rid of these radicals and turn them into fractional exponents. In the top, we get x to the 1/2. And in the denominator, we're going to get x to the 3 over 4, power over index, right? Now, we got to turn 3/4 into a whole number. In other words, we want that 3 to turn into a multiple of 4. So we're going to multiply the top and the bottom times x to the 1/4. As we said before, we're going to add these exponents together. So in the top, we'll have x to the 1/2 plus 1/4. And in the denominator, we're going to have x to the 3/4 plus 1/4. Doing our addition out, we are going to get x to the 3/4 over x to the 4/4. Very nice. Now we'll just do whatever simplification that we can. The 3/4, that's going to stay the same. We don't care too much about the numerator if we're being honest. But x to the 4/4, that turns into 1. Our final answer, x to the 3/4 over regular x. Now, in our final example here, we're going to have to produce a power of x that is going to be different than 1 at the end of the day. How can I tell? Because that 7/3 is greater than 1 already, right? So, what do we multiply this times? Well, we need 7 to turn into the closest multiple of 3 as possible. So let's multiply times x to the 2/3 here. X to the 2/3. Now, if you don't have an exponent with your variable, it's understood that the exponent is equal to 1. So in this case, we have x to the 1 plus 2/3. And down in the denominator, we're going to have x to the 7/3 plus that 2/3 again. Let's do our addition out now. That'll produce for us x to the 5/3 over x to the 9/3. Aha, 7 plus 2 is 9, and 9 can be divided by 3. As such, our final answer here is going to be x to the 5/3 over 9 divided by 3, x to the 3rd. And that's it. If you're trying to rationalize a denominator when you have something other than a simple square root, remember first get yourself out of the radicals, and then you're going to try to turn the numerator of your fractional exponent into a multiple of the denominator. In other words, what you're trying to do is produce something like 3/3 or 9/3 or 4/4 like we had in these examples here, because those fractions simplify down into whole number values. Remember that when you multiply like variables together, you have to add their exponents. And last but not least here, you'll notice that in each of our numerators and our final answers, we still have fractional exponents. The only place we are not allowed to have fractional exponents is in the denominator of a fraction. Remember these things and you'll be rationalizing along with the best of them. Thanks a lot for coming along, and we will see you next time.